Hello and welcome to Relyence training on getting started with Relyence Maintainability Prediction. In this tutorial, we'll cover an overview of Relyence Maintainability Prediction so you can start your own analysis. Note that details on adding items to the analysis tree and adding maintenance data will be covered in another Getting Started with Relyence Maintainability Prediction tutorial. To start, we are signed into Relyence and viewing the Welcome dialog. If this is not open, click the Help drop-down on the top right of your screen and click Welcome to Relyence. In the Welcome dialog, we make sure that Maintainability is selected using the module selectors on the left, and we will be using our drone example in this tutorial, so we click Open Example Analysis. If you have already opened and modified the drone example analysis, you can easily remove all of your changes and return to the example analysis in its as-applied state by clicking Revert Example in the sidebar, which is highlighted in the message that Relyence is now showing. This is not necessary in this case, so I'll click Got It to clear the message. Relyence has opened the drone example analysis, and the maintainability data window is displayed. On the screen, we can see the sidebar on the left, the analysis tree pane to the right of the sidebar. The analysis tree pane contains our system structure, and finally the maintainability data pane on the right of the screen. The maintainability data pane shows the maintainability data for the selected system tree item. Note that you can edit the structure of the analysis tree by clicking the Edit button here at the top of the analysis tree pane. Note that we will not be covering this functionality in this tutorial, but feel free to familiarize yourself with editing the analysis tree structure with the assistance of the Relyence help or the Relyence team. Each analysis tree item has its own maintainability data pane, which displays the maintainability data, including details such as maintenance tasks. In this example, the motherboard, ground controller, and motor analysis tree items each have their own maintainability data. By using the analysis tree, we can organize our maintainability data. Now, to see more of the maintainability data pane, we can simply collapse the sidebar and resize the analysis tree pane if needed, using the splitter bar. Now we'll focus on the maintainability data pane, and we'll use the motherboard subsystem as an example. On the maintainability data pane for the selected analysis tree item, we can indicate if the item is repairable, if so, define the appropriate maintenance level, and how repair data will be entered. By default, Relyence Maintainability Prediction sets the maintenance levels to those defined in MIL Handbook 472, on which Relyence Maintainability Prediction calculations are based. But note that you can customize the maintenance levels by renaming the supplied levels, as well as adding or removing levels. This is not covered in detail in this tutorial, though note that it is accomplished by simply using the Configure option from the sidebar. Relyence Maintainability Prediction allows you to define repair data using maintenance tasks or FD&I outputs. A maintenance task represents a single step that must be performed in order to repair a failed item. A number of tasks completed together to complete a repair are considered a maintenance task group. Relyence Maintainability Prediction supplies a list of common tasks from MIL Handbook 472, and you can also create your own maintainability tasks and task groups. FD&I outputs, or fault detection and isolation outputs, are the activities performed in order to detect and isolate a failed item. Relyence Maintainability Prediction allows you to create your own custom library of FD&I outputs for use in defining maintainability data. Finally, here in the Maintenance Tasks table, you can enter or view the tasks or FD&I outputs necessary to repair the item. For the motherboard example in this case, 2 hex or Allen type screws need to be removed. Then the board, a plug-in module, has to be removed and then replaced. And finally, the 2 hex or Allen type screw fasteners need to be replaced. Now that we've reviewed the maintainability data pane, let's take a quick look at an analysis tree item and its associated properties. We'll look at the quadcopter drone in the analysis tree pane. To view the properties associated with the selected item, we simply click the Properties button in the Analysis Tree toolbar. The Analysis Tree properties now appear in the rightmost pane. You can edit any data associated with the Analysis Tree item on this form. This data can also then be included on Relyence's Maintainability Prediction reports. While here on the Analysis Tree Properties form, we can click any other Analysis Tree items, such as the motherboard, to see its relevant properties as well. To return to the Maintainability data pane, we simply click Go Back. Now once all of our maintainability data has been entered, we can perform a calculation to see the resulting maintenance metrics for the analysis. To calculate, we click Calculate from the sidebar, the Calculate Maintainability Prediction dialog appears. This is where we can select the repair levels to be calculated and which calculations should be performed. For this tutorial, we'll calculate for the intermediate level and request the following calculations: mean time to repair, mean corrective maintenance time, mean preventive maintenance time, mean maintenance man-hours per repair, and mean maintenance hours per maintenance action. Note you can see the acronyms defined in more detail by hovering over the selected field. We'll also choose to calculate reliability prediction before calculating maintainability prediction, as this analysis does include reliability prediction data, including failure rates, which are important for calculating various maintenance metrics. To start the calculation then, we simply click Calculate. Upon completion of the calculations, the results dialog appears, and we can review the maintainability metrics for all calculated levels for any analysis tree item. For example, the motherboard. In this tutorial, we calculated only the intermediate level results. When we're done reviewing the maintainability metrics, we could generate a report of those metrics or simply close and return to the analysis. Next, we'll look at reporting on our maintenance data in Relyence Maintainability Prediction. Since the Report button is in the sidebar, we'll expand the sidebar. Note that the Report button is still fully functional with the sidebar collapsed, but expanding the sidebar makes the button a bit easier to find. So we see that Report button under Functions. Note that in Relyence, all reports are created based on what you have displayed, which makes reporting very simple. To report, simply click Report. The Report options appears. Here you can set a custom report title and also select which subsystems to include on the report. The Subsystems option has 3 choices: Current Subsystem, which allows you to report the maintainability data for the currently selected subsystem; Current Subsystem and All Children, which allows you to report the maintainability data for the currently selected subsystem and all child items; or Entire System, which allows you to report the maintainability data for all analysis tree items in the analysis. Let's generate the report for the entire system. Note we also have the option to customize the report header, though we'll not make any changes in this tutorial. Next, we click Report, which prompts Reliance to open a new browser tab and load the report with our data. We can easily download this report by using the Download button in the toolbar. We can select from various options including PDF, Excel worksheet, PowerPoint presentation, TIFF file which is an image, or Word document. When done viewing this report, we would simply close the browser tab and go back to Reliance. This concludes this Getting Started with Reliance Maintainability Prediction tutorial. Thanks for watching. Please visit our website or contact us with any questions or to obtain pricing and purchasing information.